Hi everyone, we are from Group 17. This is our open-ended laboratory, which is G42 Skim Rebound Harness Test. Screen rebound hammer test is carried to determine the rebound hardness of a test material using screen impact hammer. Apart from that, the screen hammer SH is an ideal index apparatus which underlies its increasing popularity and expanding range of applications. Besides, the SCH rebound hardness value is to estimate the initial compressive strength UCS and the modulus of elasticity of intact rock both in the laboratory condition and in situ. Next, it is also used to assess the porosity of rocks in mechanical means which are cutting, polishing, milling, crushing, and so on. Apart from that, the objective of screen rebound hammer test is to determine the hardness of initial compressive strength UCS of rock. Next, the theory, which is as the hammer pushes toward the rock, the forces in the hammer cause the latch or to release and make an impact on the rock surface.
Now I'm going to show you how to use screen hammer test to determine the hardness compressive strength. Below is our apparatus, which are the screen hammer, steel cradle, rock core sample, and the sandpaper. First, we need to measure the surface of the rock specimen smooth enough and clean by using the sandpaper. Then we place the steel cradle on the flat surface and clamp the rock specimen onto the steel cradle to prevent vibration and movement. Next, we compress the hammer string by depressing the plunger perpendicular to the specimen until the hammer is triggered and the impact occurs. We lock the button of the hammer and the reading of the rebound number was recorded. We repeat the experiment at several different positions to get the average value.
For calculation, we need to determine the values of UCS by using this graph. In order to get the UCS value, we need to plot a straight line from the x-axis, which is the rebound values that we obtain from the experiment. We plot a straight line and intercept to the rock density line, which is we use 27 Newton per meter cube as a rock density value. And after intercept, we can find the UCS value on the y-axis. So, this is the UCS value that we obtain from the graph. Then, after obtain all the UCS value, we need to find the average rebound value by sum all the rebound value and divided by the number of reading. Same goes to the UCS value. To find the average UCS value, we need to sum all the UCS value and divided by the number of reading.
Firstly, to determine the measurement of the weak rock strain in the field, we need a method that is fast and precise, so one of the methods is to use the index measuring device, which is SCHMIDT hammer rebound. Its result is a function empirical equation of relationship between unaxial compressive strength and SCHMIDT hammer rebound. The value of compressive strength for all the points are different. This is because every point the sample have a different strength. Next, factors like size, saturation, weathering state, and moisture content were found to affect the value of the SCHMIDT hammer rebound number. If the compressive strength is high, so the load that can be obtained might be bigger than low compressive strength. If the rock sample has a high compressive strength, so the strength for the concrete also increase. Besides, SCHMIDT hammer rebound number can also be used as an early prediction of the elastic and strength properties as well.
Hi, I'm Shukrina. So for the discussion, from the result obtained, average rebound number is 50.6 and average compressive strength is 161.9 MPa. Therefore, we realize that it is a good layer quality of rod since here it is between the range 40 to 60 average rebound number, strong to extremely strong rope, while the range for average compressive strength is between 90 to 210 MPa. This shows that the rock might be some strongly cemented sedimentary rocks or some metamorphic igneous rocks. As the value of rebound value increase, the value of UCS is also increased. The higher the rebound value, the stronger the rock. For conclusion, from this experiment we managed to obtain the hardness and unaxial compressive strength, which is UCS of granite. The average rebound values and the average of UCS obtained are 50.6 and 161.9 MPa respectively. Hence, we can conclude that the granite is strong.